Pause the video if you would like to have an attempt at the question. Okay, before we get started in earnest on this question, this is best understood by recognising that completing the square is the same as a translation of the red line that you see in front of you. So the final two functions, we could think of picking up that red line, moving it left or right and up or down after we've completed the square, and that will move the minimum point around. But they are exactly the same shapes. All of these curves are the same shapes. So that gives you kind of a bit of information about the gradients of each curve and whether they cross or don't cross. We are going to start the question now. And here we go. If we just investigate that first equation, we can see the roots. It's going to be a big happy smiley face. And if we complete the square, we can identify where the minimum point is. In fact, what we're doing to draw this is we are taking the red curve and we are moving it 1 unit to the right and 1 unit down. Now, if every point on the line goes 1 unit to the right and 1 unit down, that blue line is not going to cross the red line. It's going to stay to the right-hand side of that. And similarly, on the other side, the blue line is going to get steeper more quickly than the red line on the left, and so they won't cross. So we only have one point of intersection between the lines. If we do the same thing to the second equation, we cut through the red line on the left hand side and the blue line on the right hand side, but we don't have any more points of intersection. And if we count up the numbers of areas, we have 7 of them. That first area goes all the way around underneath the bottom.